The date has passed, December 19th, 2025, the day the world held its breath and exhaled too soon. The world watched as 3I Atlas swung by and apparently did nothing. No invasion fleet, no visible communication, just a silent passage at 270 million kilometers. But if you think the story is over, you haven't been reading the latest papers. While the media packs up their cameras, the astrophysicists are just starting to panic. Or rather, plan. What if this object isn't just a visitor? What if it's a vehicle? And what if the most serious scientists on Earth are now discussing how to catch it? Not to study it, but to ride it. Welcome back. Today, we are tearing apart the newest data released in the last 48 hours. New radio scans, a new size estimate that changes the physics completely, and a proposal from Harvard's Avi Loeb that sounds like science fiction, but might be our only way out of this system. If you want to know humanity's next move, make sure you're subscribed. You do not want to miss the Jupiter rendezvous updates coming in March. First, let's address the elephant in the room. The flyby. December 19th came and went. The object passed at a safe distance, invisible to the naked eye. Skeptics called it a victory lap. Just a rock, they said. It didn't stop. It didn't signal. It just kept going. But that keeping going is exactly what has visionary scientists excited. Professor Avi Loeb, the man who first suggested Oumuamua might be artificial, has just released a new analysis. And he's no longer just asking, what is it? He's asking, what can we do with it? His latest proposition is radical. He suggests that interstellar objects like 3I Atlas are not just curiosities. They are transit systems. Think about the Voyager probes. Voyager 1 and 2. We launched them almost 50 years ago. They are the fastest objects humanity has ever built. And yet, they have barely scratched the surface of interstellar space. It will take them 30,000 years to reach the distance of the nearest stars. 30,000 years. Civilization might not even exist by then. But 3I Atlas? It is moving at 60 kilometers per second. It is exiting the solar system much faster than anything we have ever launched. Loeb's argument is simple. Why build a slow ship when a fast one is already passing by? He is proposing that we use 3I Atlas as a carrier, a cosmic freight train. If we can intercept it, or the next one like it, we could attach a payload, a probe, a time capsule, a message in a bottle. If we could hitch a ride on this object, we could reach the depths of interstellar space by the year 10,000 AD. That is still a long time, but it is 3 times faster than Voyager. It cuts the travel time by 20,000 years. And here is where it gets personal. Loeb said he would be willing to donate his own biological remains to such a mission, to have his DNA carried out into the galaxy on the back of an interstellar visitor. It's a poetic idea, becoming an interstellar traveler after death. But it raises a terrifying technical question. How do you catch a train that is moving at 60 kilometers per second? We can't land on it. Not easily. The energy requirements to match that speed are beyond our current chemical rockets. But Loeb suggests we don't need to land. We could use a high-powered laser to engrave a message onto its surface as it flies by, a tattoo on the hull of an alien craft. Or we could design a specialized interceptor, something small, light, and incredibly fast, to crash into it and stick like a barnacle on a whale. This changes the paradigm. We aren't just looking at these objects as threats or scientific puzzles anymore. We are looking at them as infrastructure. But before we start packing our bags for the stars, we need to understand what this train is actually made of. And the latest data on that is confusing. A new paper has just been published regarding the size of 3I Atlas. For months, we've been debating how big it is. Is it a shard? Is it a sphere? Is it a massive mothership disguised by dust? The new analysis combining data on the object's non-gravitational acceleration. That's the extra push it gets from venting gas, suggests a nucleus diameter of approximately 1 kilometer. 1 kilometer. That is small. That is significantly smaller than the city-killer asteroids we usually fear. But here is the catch. A 1-kilometer rock should not be behaving the way 3I Atlas is behaving. The paper notes that to produce the amount of dust and gas we are seeing, the massive tail, the coma, a 1-kilometer object would have to be shedding mass at an incredible rate. It would be evaporating before our eyes. Commenters on the paper are already pointing out the flaw. A 1-kilometer nucleus can produce all that debris? Wouldn't it have broken up? Exactly. If it's a natural ball of ice, and it's venting that hard, it should be disintegrating. It should be falling apart under the stress. But it's not. It's holding together. This implies one of two things. Either it is made of something incredibly dense and strong, something that can withstand massive structural stress while venting like a geyser. Or, the venting isn't natural sublimation. If it's a machine, a 1-kilometer hull is massive. That's a star destroyer. That's a generation ship. And the gas we see, that's exhaust. And speaking of exhaust, let's talk about what is coming out of it. Because there was a real fear that 3I Atlas might be dusting us, that it might be dropping biological or chemical agents into our atmosphere. We know the coma contains cyanide. We know it contains hydrogen cyanide, deadly poisons. Avi Loeb addressed this in another update titled, "Will material from 3I Atlas arrive on Earth?" The short answer, thankfully, is probably not. The solar wind is our protector here. The stream of particles from the sun is pushing the gas and dust away from Earth. Loeb calculates that any particle smaller than a micrometer gets swept away instantly, and any large chunks, rocks bigger than a meter, are too sparse to hit us statistically. So, we aren't going to be poisoned by the comet's tail. Unless, and Loeb adds this caveat himself. This, of course, is under the assumption that the released objects cannot maneuver by technological propulsion. If the dust isn't dust, if the rocks are drones, then the solar wind doesn't matter. They can fly where they want. And that brings us to the radio silence. We have been listening. The Allen Telescope Array spent over 7 hours pointing directly at 3I Atlas on July 2nd. They were looking for technosignatures, radio beacons, Hail Marys. They found 74 million signals. 74 million hits. Now, before you panic, that is normal. The sky is full of noise. Satellites, GPS, terrestrial interference. The job of the astronomers is to filter that noise out. They filtered it. They removed the interference. They removed the known satellites. They were left with 211 hits. 211 signals that came from the direction of the object and didn't match known background noise. They analyzed them visually. They looked at the waveforms. And the conclusion? No signals worthy of additional follow-up. They dismiss them. They say it's just noise. But look at the upper limit they established. They determined that if there is a transmitter on 3I Atlas, its power is between 10 and 110 watts. Think about that. 100 watts. That's a light bulb. If 3I Atlas is transmitting, it's whispering. It's not shouting. It's not broadcasting a message to the whole planet. It's using a low-power, directed beam. Why would an interstellar probe use low power? To save energy? Or to avoid detection? If you are a surveillance probe, you don't scream. You burst, transmit. You send encrypted, low-power squirts of data to a relay. And where is the relay? Well, remember where 3I Atlas is going next. Jupiter, March 16th, 2026. The object is heading for a close encounter with the king of planets. 53 million kilometers. If 3I Atlas is a probe, and it has gathered data on Earth, and it is now moving to the outer solar system, Jupiter is the perfect place to upload. The magnetic field of Jupiter is a massive booster. It's a natural antenna. We might have missed the signal on Earth because it wasn't meant for us. It's meant for the network. So, where does this leave us? The object has passed Earth. It is intact. It is moving fast. It is silent on the radio bands we are checking. But the story has shifted. We are no longer just watching a rock. We are watching a potential exit strategy. We are watching a mystery that defies the physics of its own size. And we are watching it head towards the one planet in our solar system that could hide a massive secret. In the next part of this video, we are going to dive deep into the Jupiter anomaly and why the scientific community is suddenly so interested in a mission that was supposed to be about icy moons. Stay tuned. The ride is just beginning. Let's talk about Jupiter, because that is where the endgame begins. On March 16th, 2026, 3I Atlas will pass within 53 million kilometers of the gas giant. To an astronomer, this is a gravity assist, a slingshot. The object is stealing momentum from Jupiter to fling itself out of the solar system even faster. But to a strategist, this is a rendezvous. Why? Because Jupiter is the crossroads of the solar system. If you are entering or leaving, you use Jupiter. It is the gravity well that shapes the highway. And 3I Atlas is hitting that highway with surgical precision. The new data confirms the date and the distance. 53 million kilometers. That might sound far, but in cosmic terms, it is a near miss. It is close enough to feel the massive magnetic field of the planet. Close enough to be affected by the radiation belts. And this brings us back to the 1 kilometer diameter estimate. If 3I Atlas is truly that small, a tiny dense needle in a haystack, then hitting that specific window at Jupiter requires incredible navigational accuracy. It entered the solar system from above the plane, dove down past the sun, missed Earth by a safe margin, and is now threading the needle at Jupiter. If this were a dumb rock, it's a lucky shot. But we know it's not just falling, it's pushing. The non-gravitational acceleration is the key. The new paper confirms it. The object is speeding up more than gravity alone can explain. The official explanation is outgassing. The comet is heating up, ice is turning to gas, and that gas is acting like a rocket thruster. But remember the problem? A 1 kilometer object shouldn't have enough ice to push it that hard without falling apart. So, what if the push isn't random? What if it's a course correction? If 3I Atlas is an artificial probe, it is currently executing a burn. It is adjusting its trajectory to ensure it hits that March 16th window perfectly. Why? Maybe it's not just leaving. Maybe it's meeting something. We have probes at Jupiter. The Juno mission is there. The European JUICE mission is on its way, though it won't be there yet. But Juno is active. NASA says Juno isn't designed to track fast-moving interstellar objects. Its camera, JunoCam, is a public outreach instrument, not a high-speed tracking telescope. They are already managing expectations. Don't expect a close-up. But do you really believe that? If an alien craft, or even a potential alien craft, is flying past our biggest planet, and we have a billion-dollar asset sitting right there, do you think they are going to leave the lens cap on? There is a theory circulating that the radio silence we heard from the Allen Telescope Array wasn't total silence. Remember the 10 to 110 watts limit? If 3I Atlas transmits at 50 watts, we can't hear it from Earth easily. The background noise is too high. But Juno is right next door. If 3I Atlas pings Jupiter, Juno will hear it. And this might be why the narrative is shifting to transport. Avi Loeb's suggestion to hitch a ride implies that we accept the object is leaving. We accept we can't stop it. So we try to tag it. But there is a darker interpretation of the transport theory. What if we aren't the ones supposed to hitch a ride? What if 3i Atlas came here to pick something up? We talked about the material it might have dropped, the cyanide, the dust. But a transport mission works both ways. Drop off a payload, pick up a sample. The object dipped into the inner solar system. It got close to Earth. It tasted our solar wind. It sampled our dust. And now it is accelerating out. If it collected data or biological samples from our upper atmosphere, that data is now on its way to the stars. And we have no way to get it back, unless we intercept it. This is where the Project Lyra discussions come into play. Scientists have been proposing a mission to chase down Oumuamua for years. But Oumuamua is long gone. 3i Atlas is still here, but the window is closing. To catch it, we would need to launch now. We would need a rocket ready on the pad. We don't have one. So the hitchhiking idea, using lasers to send a message, might be our only option. It's a desperate attempt to say, we are here, to write our name on the side of the passing train. But let's look at the destination again. After Jupiter, where does it go? The trajectory takes it towards the outer dark, past Saturn, past Pluto, into the Oort cloud. And then, the new calculations show it heading towards the Hyades cluster, specifically towards Epsilon Tauri. Why there? Epsilon Tauri is a giant star. It has a massive debris disk. It is a system rich in materials. If you were building a galactic network, a highway for these transport objects, Epsilon Tauri would be a major hub, a construction yard. 3i Atlas might be a drone on a supply run. It swings by Sol, uses our gravity, maybe scans our biology, and then heads back to the hub. And we are just the ants watching the truck drive by on the highway. But there is one more twist in the new data. The diameter estimate paper mentions something strange. It says the momentum imparted to the nucleus could be dominated by the ejection of fragments. Fragments, not gas, chunks. The object isn't just venting steam, it is dropping pieces of itself. The authors suggest these are icy fragments. But if we go back to the transport theory, what if these fragments are the passengers? What if 3i Atlas isn't the bus? What if it's the aircraft carrier, and it just launched a squadron? If those fragments are independent probes, they wouldn't be leaving the system. They would be braking. They would be using the kick from the ejection to slow down and enter orbit. We are looking at the main object speeding up and leaving. We are waving goodbye to the mothership, but we should be looking for the lifeboats. If there are 1 meter or 10 meter objects that separated from the main body, they would be incredibly hard to see. They would be dark. They would be cold. And they would be parking themselves in stable orbits, like the Lagrange points, or high Earth orbit. The radio silence from the main body makes sense if its job is done. It dropped the package. It's going home. But the package might just be waking up. In the next segment, we are going to talk about the fragments and why a sudden series of meteor sightings and satellite anomalies might be connected to what 3i Atlas left behind. Because if Avi Loeb is right, and this is a transport system, it didn't come here empty. Don't go anywhere. Let's talk about the fragments. The scientific paper uses the term ejection of fragments to explain the momentum shift. They model it as ice breaking off. But let's look at the timing. These ejections happened right at the perihelion, right when the object was closest to Earth. If you were deploying sensors, or drones, or seeds, that is exactly when you would do it. You use the gravitational slingshot to scatter your payload. And now, look at the news from the last 48 hours. Have you noticed the meteor showers? Astronomers are calling it a late-season Geminid surge, but the Geminids peaked weeks ago. These new fireballs are different. They are slow. They are orange. And they are entering the atmosphere at angles that suggest they are catching up to Earth, not hitting it head-on. That means they are in a similar orbit. If 3I Atlas dropped a cluster of small objects, let's call them the swarm, they would be drifting alongside us right now, and some of them are coming down. But not all of them. Reports are surfacing on the dark web and even leaking into mainstream aviation forums about GPS anomalies. Pilots over the Pacific are reporting loss of signal. Starlink satellites are experiencing unexpected drag. SpaceX has been quiet, but the orbital decay data is public. Something is creating drag in the upper atmosphere. Something that wasn't there last month. Is it dust? Is it the cyanide cloud we talked about? Or is it active interference? If the fragments are technological, they might be latching onto our grid. They might be the interception mission that what we didn't launch. And this brings us back to the panspermia angle. The spectral analysis of the Comet showed cyanide. It showed organic precursors. The building blocks of life. Avi Loeb says the solar wind will blow the small stuff away. But what if the stuff isn't small? What if it's encapsulated? If you wanted to seed a planet, or update its biosphere, you wouldn't just spray gas. You would send canisters. You would send protected samples that can survive re-entry. The orange fireballs people are seeing. Maybe they aren't burning up. Maybe they are heat shields. We need to stop thinking of this as a flyby. A flyby implies a tourist taking a photo. This feels more like a crop duster. And we are the field. Now, let's look at the reaction from the world governments. Or rather, the lack of it. The interception narrative has shifted. A few days ago, they were talking about chasing the comet. Now, the talk has turned to defense. The article about interception strategies mentions kinetic impactors. That means hitting it hard. Why would you want to hit a rock that is leaving the system? Unless you are trying to stop it from transmitting. If 3I Atlas is sending data back to Epsilon Tauri, data about us, about our defenses, about our biology, then letting it reach Jupiter is a strategic failure. Once it hits Jupiter's magnetic field, it has the power to broadcast that data across the galaxy. So, the plan might be to kill the messenger. But how? We can't catch it with a normal rocket. It's too fast. The only thing we have that is fast enough is a laser. Avi Loeb proposed using a laser to write a message. But a laser powerful enough to write on a comet at that distance is also powerful enough to heat it, to vaporize it, to blind its sensors. There are rumors that the Breakthrough Starshot laser array, the one designed to send tiny probes to Alpha Centauri, is being repurposed. Not for propulsion, but for targeting. We might be witnessing the first interstellar shot fired in anger, and the target is the transport system that Avi Loeb wants to ride. Imagine the irony. The greatest scientific discovery in human history, a potential bridge to the stars, and our first instinct is to burn it down because we are afraid of what it might tell the neighbors. But there is a risk. If we fire on it, if we disrupt it, do we trigger a failsafe? Remember the fragments. They are still here. They are in orbit. They are in our atmosphere. If the mothership is attacked, do the drones react? We might be poking a hornet's nest while standing inside the hive. And the clock is ticking. March 16th, 2026. That is the deadline. That is when 3I Atlas reaches the Jupiter relay. If the governments are going to act, they have to act before then. We are entering a silent war. A war between the desire to explore and the instinct to survive. Avi Loeb wants to send his DNA to the stars. The military wants to make sure the stars don't come back to us. And in the middle of all this, we have the anomalies, the glitches, the fireballs. I want you to watch the sky tonight, not for the comet. It's gone. Watch for the slow meteors. Watch for the orange streaks. And if your GPS fails, if your internet cuts out, don't assume it's just a technical glitch. It might be the fragments coming online. In the final part of this series, we will look at the Epsilon Tauri connection. Why that star? What is waiting there? And what happens if the message in a bottle actually gets delivered? Because if 3I Atlas is a transport, it's eventually going to come back. And next time, it won't be just a flyby. Stay paranoid. Stay watching. Finally, let's talk about the destination, Epsilon Tauri. Why there? Why is this object, which has traveled for thousands of years through the void, adjusting its course to hit this specific star system? Epsilon Tauri is not just any star. It is an orange giant, a massive, dying star in the Hyades cluster. It is 146 light-years away. It has a confirmed planet, a gas giant much larger than Jupiter. But more importantly, it is old. The Hyades cluster is 625 million years old. That is young for a star cluster, but old enough for a civilization to have risen, peaked, and perhaps moved on. If you were an advanced intelligence and your star was expanding into a giant, consuming your inner planets, what would you do? You would build an ark or a network. You would send out probes to find new homes, to find resources, to find biology that you can harvest or integrate. 3I Atlas is heading back to Epsilon Tauri. It is completing a circuit. Think of it as a bee returning to the hive. It went out. It found a flower, Earth. It collected nectar, our data, our DNA, maybe even our fragments. And now it is flying home to dance and tell the others where the food is. And this is where Avi Loeb's message in a bottle idea takes a terrifying turn. He wants to send a message out. He wants to tell the universe, we are here. But what if the message 3I Atlas is carrying isn't a greeting? What if it's a menu? If the object is a transport and it's bringing samples back to Epsilon Tauri, then in 10,000 years, or much sooner if they have faster than light communication, the hive will know we are here. And they will know exactly what we are made of. They will know our defenses. They will know our biology. They will know our weaknesses. The transport system isn't just for them. It could be for us, but not in the way we think. Maybe the next ship that comes won't be a 1-kilometer probe. Maybe it will be the harvest fleet. But let's step back from the fear for a second. Let's look at the opportunity. Avi Loeb is right about one thing. We are stuck here. We are trapped in this solar system by the tyranny of distance. Our rockets are too slow. Our lives are too short. If there is a galactic highway, if there is a network of these objects moving between stars, then we have a choice. We can hide. We can shoot at them. We can try to destroy the bridge, or we can try to cross it. If we can catch 3I Atlas, or if we can catch one of the fragments it left behind, we might find the key to the engine. We might find the map. We might find that we aren't alone, and that the galaxy is a busy, thriving place, and we've just been living in the suburbs, afraid of the cars driving by. The anomalies in our atmosphere, the glitches in our satellites, maybe they aren't an attack. Maybe they are an invitation. Maybe the fragments are waiting for us to find them, to interface with them, to prove that we are smart enough to join the network. The test isn't whether we can blow up the comet. The test is whether we can understand it. So, what happens next? March 16th, 2026. The Jupiter rendezvous. If the governments decide to strike, we will see a flash. A new star in the sky, briefly outshining Jupiter. And then, silence. But if they decide to listen, if they decide to let the message go through, then we might get a reply. It won't come tomorrow. It won't come next year. But the connection will be made. And in the meantime, we have the dust. We have the orange meteors. We have the seeds that are falling on our world right now. Maybe the transport has already arrived. Maybe the passengers are already here. And maybe, just maybe, They are us, or what we are about to become. I will be tracking the orbital decay of the fragments. I will be monitoring the signal from Jupiter, and I will be right here, updating you on the end of the world, or the beginning of the next one. If you want to be part of the network, hit that subscribe button, turn on notifications, because the signal is getting stronger, and you need to be ready when the transmission completes. This is 3i Atlas, and it is not done with us yet. Thanks for watching, stay safe, and keep looking up.